Hi, it's time for another math easy solution. Today I'm going to go over a pretty epic video. This is going to be on the cubic formula and its proof. So it's going to be quite epic. And as always, if you don't have time to watch this whole video, you could play this video at a faster speed. There's no summary and conclusions in this video, just a final answer. And top secret life hack, your brain gets used to faster speed, and there's a link to it. And also you can download and read the notes in PDF or article format on the Hive blockchain. All the links will be in the description below. And also you can watch the video in parts, and I'll be putting timestamps in the video description. Alright, so let's just jump right in. So first of all, I'm going to go quick recap on the quadratic formula. So just a quick recap and the proof that I used for it. I'm not going to go over the proof like manually. I'm just going to show you what I did. So recall from my earlier video on the quadratic formula. So if you had the quadratic, basically the power of this polynomial is just x squared. Yeah, so highest power is 2. So ax squared plus bx plus c equals 0. Then basically if you solve this out, the answer for x is going to equal to minus b plus or minus square root b squared minus 4ac. And in that video, I used, I derived it by completing the square. So the reason I'm going over this derivation is because we're going to use a different one to help with our cubic formula proof. So in that video, I derived it by completing the square. And basically, here's the steps that I did. So if you have this ax squared, etc., I divided out a to get rid of it in the front. So you have b over a plus c over a, like that equals 0. And then what I'll do is complete the square. So in other words, write this out as a x plus d, and then all squared. Expand this out. We're going to get an x squared plus 2dx plus d squared. Now we line up this b over a with 2d. So equate these. So now we have now we could solve for d. D is equal to b over 2a. So we can plug this in. So we're completing the square. So now we have a x plus b over 2a, and then all squared. And now we're going to have to minus, because this term includes a plus d over plus d squared. So we're going to have to minus that. So minus d squared, and d is right over here. So minus b squared over 2a squared. And then finally there's this is a plus right there. This should be a plus c over a. Yeah, and then this all equals 0. So now what we'll do is we move this whole thing over to the other side. So move it over to that side, and then take the square root, and then what we could also do is simplify it further. So now this one's going to be plus here, this is going to be a minus, and it's going to be b squared over 2a all squared, and then minus. Now this one here, we're on the same common denominator, so this 2a all squared. To do that, we multiply the top and bottom by, well, this is going to be 4a over 4a. And then, so then your a squared, 4 is just 2 squared. So you'll have an a squared, 2 squared, put those together, 2a, and the top's going to be 4ac. So again, just quickly go over this. And then, finally, because we're square root is going to be plus or minus the square root, because it could be plus or minus when you're dealing with squares. For example, minus 1 times minus 1 is 1, same thing as 1 times 1. So again, and now this part here, we're going to move this over to the other side, so we're going to have a negative, and then put this all neatly, and these all have the same common denominator. This is 2a squared, but then square root is going to be 2a. Combine those, we're going to have x equals to a negative b plus or minus square root b squared minus 4ac, all divided by 2a. Alright, I just put that there for completeness. Again, all these notes will be in the link in the description below, PDF or article format on the Hive blockchain. And if you're already aware of this, you could just already don't need a refresher. You can skip all these into timestamps and so on. But again, get to refresh it because it will help in the proof. Alright, so now let's take a look at the cubic formula. So the cubic formula is the solution to the cubic equation. So if you have this one, so instead of ax squared, now we're dealing with an ax cubed, so a higher power. So ax cubed plus bx squared plus cx plus d equals 0, where a is not equal to 0. Otherwise, if it's equal to 0, then we're just left with a quadratic formula. All right, and so on. So what we'll have is, and this is the solution. It's from that I got it from that YouTube video, and I'll go over soon. That red pen, black pen, or whatever it's called. Anyways, so this is the solution. There's actually 3 solutions as opposed to the previous one. This one had 2 solutions. This had there's a plus or a minus one. Now we have 3 solutions because it's a cubic root. So we have this cube root minus b to the power of 3 divided by 27a3, etc. It looks all complicated, but some of these terms are identical. Like this one's identical with this inside. And then this one's identical with this. And then again, this is identical with this. So again, it's all complicated looking, but there's a bunch of similar terms. And then there's another part here to learn up. This is some complex numbers multiplied by it. So it's actually these are in the complex plane as well. This one is just a real number. Now this, because you can also have solutions in a complex plane for this. Whereas this one you could have a real or complex. But then if the scenario arises where this is a negative root, you can have a complex one. So this one's already incorporated in it. This one you have to include the complex ones separately like that. As you can see, there's imaginary terms right there. This I squared 3 divided by 2, etc. All right, so the question is, how do we get from here all the way to here? All right, so now let's finally take a look at the derivation. So derivation of the cubic formula. So I'll be following the steps done by the big YouTube channel, Black Pen, Red Pen's derivation. So I'll go over that video there. And the first step is actually, well, it's a step 0. It's basically to solve the quadratic formula using a new method called a PQ substitution method. And this will help in our derivation of the cubic formula. So let's do this method right here. So let's say we have our ax squared plus bx plus c. This equals 0. All right. So now the first thing to do is same as before. Just divide everything by a. Divide everything by a, like this. And now what we end up having is, well, this term here, so this one will cancel, the 0 is still 0, but this part right here, this will be, we'll call this p, so p is equal to b over a, and then this part right here, we'll call this q, so q is equal to c over a. So what this ends up being is, we get now x squared plus px plus q equals to 0. Alright, so now this is just a parabola. So what we could do is, well, we could just shift this. This is the strategy, is to shift this parabola. And we can shift this just by updating the x squared term there. I mean, all the x terms. We'll just update it by constant k. So shift parabola to basically to remove all of the, just remove the px term. So we want to cancel that out. So to do that, we will let x equals to y plus k. So we're just shifting it by constant k. So plug all this inside. We're going to get the x will be now y plus k squared. So this is going to be that. And the next one, px, is going to be, well, p times it by y plus k. And the next one's going to be q equals 0. And now we could expand these out, but all that matters is just the y, k, and py terms. But I'll just do it for completeness, the entire thing. So expand out y plus k squared. Well, y times y is y squared plus y times k. Then do that again, plus k times y is going to be now 2ky plus next one is k squared. Next one is going to be now expand this out plus py plus pk. And then plus q equals to 0. So again, we want to cancel out the px term. So in this case, we shifting it by k, so we'll get rid of the py terms. So we're going to get rid of this one here, and this one, 2ky. Yeah, so in other words, we want 2ky plus py equals to 0. Yeah, so then basically the y just cancel out the y. We're going to get this is going to be k value, and shift over to the p to the negative side, so negative p divided by 2. So k equals to p minus, negative p divided by 2. Alright, so what this means is we could throw this inside, so throw this inside, and what we end up having is, we're going to have a y minus p over 2 squared plus, and now we're going to have a p, and then we're going to have a y minus p over 2 plus q equals 0. Alright, so now just expand this out again, just for completeness, just do it all. We could have just started off from this line already, because we already know what k is, but anyways, we'll just do it all from the beginning, just to show you that they'll cancel out anyways. So y times y is going to be y squared, minus, it's going to be now 2 times it by, these are going to be, this is going to be negative, so y times negative p over 2. Do that twice. So what that ends up happening is we'll just have a negative 2, then p over 2y. And then the next one's going to be plus p squared over 4, like that. And that's because, well, negative times negative is positive, so we'll leave it like that. Next one's going to be multiply this one here, so p times y, and then minus p squared over 2. And then this is going to be plus q equals to 0. And now the next setup here is, well, this is going to cancel with this. Now we're going to have a negative py and a py, so then these cancel out. I'll just leave it like this. Cancels out with this. And now this one here, we're going to have a p squared over 4. This one's a negative p squared over 2. So multiply top and bottom by 2 so that we get 4 the denominator. And then this ends up being, well, we get a y squared plus, this is going to be p squared over 4 minus 2 over 4. So we're going to have a negative p squared over 4 and then plus q equals to 0. Alright, so now we could just take this over to the other side, move everything there. So we're going to get a y squared, but we're going to square root it. So this is going to be, move this over to the other side, this to the other side. We're going to get a, now plus or minus, we're taking the square root. This is going to be square root p squared over 4 plus q, minus q. This becomes minus, this other one's minus becomes plus, like that. And we know that, we know that y, well, y is just equal to, this just equal to, well, we know that x is equal to y plus k. So then y equals to, well, x minus y equals to, x minus k. X minus k, which equals to x, and then minus k is going to be plus pi over 2. Plus p over 2, like that. So it's going to be plus p over 2. So now this one we could shift over to the other side over there, and we solve for x. So x is going to equal to, this is put that in the front. So negative p over 2 plus or minus square root p squared over 4 minus q. Alright, so now I'm just going to box this in. And this, this is the PQ substitution method, and we will be using this method in their cubic formula derivation. Alright, and now that we have this, the PQ substitution method for the quadratic formula, we could apply the same thing for the cubic formula. So, step 1, get rid of the x2 term, or x to the power of 2 term, using the PQ substitution method. So just as in the PQ substitution method for the quadratic equation, we would like to get rid of the x to the power of 2 term from the cubic function. So if we have a to the power of x cubed plus bx squared plus cx plus d equals 0, we want to get rid of this one here, and the reason is because it's possible to solve the equation y to the power of 3 plus py plus q equals 0 by applying a Vieta's substitution to obtain a quadratic formula. So basically, if we apply the PQ substitution to this one, we would get something like this. And now we can apply a thing called Vieta substitution, and we can obtain a quadratic formula which we can solve. So basically, what the idea is, well, we can apply, so the Vieta substitution, you'll apply something like this: y equals to z plus something on top, and then a z at the bottom. And the reason is we're going to get here, so apply here to get, I'll just put it here, or apply that and get, and we're going to get a function such as, well, if we apply this y equals inside here, this y cubed, now it's going to be z cubed. You're going to get something that looks like this: z cubed plus like this, and then something divided by z cubed at the bottom, dot 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 equals 0, and this is we can actually write this as a quadratic formula, and we can solve this out. So this is the goal. Again, I'm following the steps from that big YouTuber. And formula. So that's the idea, and now let's just try to get it in this form. So to do that, let's apply the PQ substitution method to the cubic function. So let's write this all down first. So we have our cubic formula, or cubic function a, x cubed plus bx squared. Write this better. And then plus cx plus d equals to 0. Yeah, so what we'll do is we'll shift this. What we'll do is, let x equals to y plus k. So we're going to shift it and then try to get rid of the x2 terms. So this all becomes now, so it's going to be a, the x cubed is going to become now y plus k cubed, cubed plus by plus k squared, and then plus c y plus k, and then plus d equals to 0. Alright, so now we want to basically choose k such that we're going to cancel out this y, all the y squareds. So to do that, well, first of all, if we expand this one out, you're going to have something like this, where, this is a square, so the only way you're going to have a y squared is when you have y multiplied by y. So in other words, you're only going to have that one time. You're not going to have a y times k, then k times y. So it's going to be, multiply this b inside. We're going to have a term like this, b y squared, and then we're going to have something like plus dot dot dot. I'm not going to expand that out because that all we care about is the y squareds. All right, so that's for that one. But then for this one right here, this part right here, we're going to get something like this. Yeah, so this is a cubic function. So we're going to have a, and then we're going to have a y plus k times by y plus k times by y plus k, like that. And now the only way to get a y squared is, well, there's three ways. We can go y times y, so that's a y squared. The next one needs to be a k there. So in other words, we're going to get, this part's going to be equal to, I'll put this equals to a, and then y squared k, like that. Now the next one is going to be, well, we can do a y times it by k, and then times it by y. Yeah, so in other words, we're going to get another term like that, a y squared k. And now the last one is, well, this one here, we can multiply this k with this y, and then with this y over there. So in other words, we're going to get another one. That's the only ones that we can do. So we're going to get a y squared and k. And now for completeness, I'm just going to write this whole thing out as plus dot dot dot, because you're going to have other stuff there, but all we want is these ones here. We're not dealing with the y cubes or whatnot. And then this equals to, well, this is going to sum it all up. It's going to be 3. They're all exactly the same. So 3ay squared k, like that. And then just for completeness, because we're saying that this whole thing equals, and it's plus dot dot dot. Yeah, we want this right here to cancel out with this. So what we'll do is just add those up and make them equal to 0. So 3ay squared k plus by squared equals to 0, like that. So then the y squareds, I'll just divide them all out. They all cancel out. And now what we'll do is move the b to the negative, the other side, and then solve for k. It's divided by 3a. So we'll have k is equal to negative b over 3a, like that. Alright, so that's what we have. And then we could plug this inside and continue further. But before we get further, I wanted to note here, so notice how this power of 3, we had to multiply this 3 times. So we have this 3 there. Whereas when you do the quadratic, just a power of 2, and expand that out, you get a 2 and so on. And I'm just going to do a quick recall of the Pascal's triangle. So this one right here, recall Pascal's triangle, just because we'll be using this in our expanding out powers of 3. So Pascal's triangle. So if you have, let's say the first one, you have just x, like that. The coefficient is just going to be 1. And then let's say we had a x plus 1 squared, like that. This expands out to become, well, x squared plus 2x plus 1. And Pascal's triangle, this becomes a 1, 2, 1. The next one is going to be, well, Pascal's triangle is going to be, well, you add these up. 1 plus 2 is going to be 3. Then 2 plus 1 is 3. And the next one is going to be 1, like that. So all the adjacent ones. And the next one is going to be for the cubed. And this one's going to be x plus 1, 3. So what ends up happening here when you expand this out, you're going to get again, this is why there's 3 there, because again, notice how you multiply it 3 times there. This is actually going to become a x cubed plus 3x squared plus 3x, like that, and then plus 1. And it keeps going on and on and on and on. And then for the fourth one, you're going to have this 1 plus 3, you're going to have a 4, and so on. There, so you can tell the constants in front of the coefficients of these using Pascal's triangle. Alright, so now that we have this k equals a negative 3b over, a negative b over 3a, and also Pascal's triangle, we'll use that for later. So now we can throw this inside here, and just replace it all, and then expand them all. So we're going to get now we're going to get, throw this inside. So this goes here, and this goes in it, and we're going to get a y minus b over 3a cubed, and then plus b, the next one's y plus k, like that, y minus b over 3a squared, and then the next one's going to be c, y minus b over 3a, like that, and then the next one is d equals 0. So now, what are we going to get here? Alright, so now, let's just expand this out. So this first one is going to be, we'll leave the a out there. Yeah, it's going to be, I'll put this like this. This is going to be a times it by, now y times it by itself, 3 times y cubed, like that. Next one's going to be, now this one, again, using Pascal's triangle, this is y, this is going to be the x squared. In other words, we're going to have y squared and a coefficient 3, because we do this 3 times. So what we'll do is this one multiplied by itself twice, and then this is going to be multiplied by this one. So that's a negative 1, so we'll have a negative sign. We're going to get a b, and put the coefficient 3, b, 3b over 3a, and then y squared. Now the next one is multiplied by this y once, this one twice, and that's twice. We get rid of the minus sign, we get plus b squared over, this is going to be 9, 3 squared is 9, and then also coefficient 3, and then 3 over 9, this is a squared, and then this is going to be a y there. And then the last one, this one multiplied 3 times, we're going to have a negative because it's power of 3, negative b cubed over 27 a cubed, like that. Now the next one is going to be this part right here, plus b, and then that's the power of 2, this is going to be y squared minus, this is going to be coefficient 2. 2b, and this just multiplied, because you're multiplying y in this one, so there's no squared, over 3a, and this is going to be y. Now the next one is going to be this multiplied by itself, so negative becomes positive, positive, b squared over 9a squared. Lastly, now add those up, this is going to be plus cy minus bc 3a, then plus d equals to 0. So now we got this. Now we could just expand all these out, or just multiply the a inside and simplify. So we get a y cubed. This cancels, a cancels. We're going to get left with a b y squared. Plus, this is going to be 3, and this one is going to be 3. Well, it's cancelled out, and this a squared cancels. We've got an a, so we got 3a b squared y. Then minus, this a multiplies here, this cancels. We're going to get a b cubed over 27a squared instead of the cubed. A squared. Lastly, this is going to be b y squared minus 2b squared. Try to squish everything in. 3a plus b cubed over 9a squared. Then plus cy. Like that. Yeah, plus cy minus bc over 3a plus d equals to 0. Alright, so now let's see if we got this all right. Alright, this is quite a lot of algebra. So let's just write this out. So the first one, a cubed, there's nothing else there. So a y cubed. Now this one here, this by squared, this is a negative by squared. This cancels with this one. And now we get rid of our y squared as what we wanted to do with our setting this k value. So we get rid of these y squareds. So get rid of them. Now the next one here is this b squared over 3ay. there's another one here over 3a, like this. So, and that's a 2 there. So we can add these up. So add this one and this one up together. And that's just going to be, well, this is a negative 2. This is a plus 1. So it becomes just a negative 1. So it becomes a negative b squared y over 3a. Like that. I'll put the y like this. All right. And also, actually, before we even do that, we have another y here. So we basically collect all like terms. So there's another y there. So what we'll do instead is I'll shift this over. So I'll do a minus, but then I'll do a plus, and then put this in bracket. Now we have the plus c there, and then we have a y there. Y, like that. All right, now the next one, I'm going to put another bracket for all the ones without any y terms. So we have a this part right here. Yeah, we have, well, we could do this one here. So this one right here, and this right here has a squared, this is 9. But we'll do, this is 27, so what we'll do is multiply by 3. So 3 times, so now we get a 27 and a 3, and then minus a 2, so that becomes a positive 2. b3 over 27. And then a squared like that. And then the next one is just these part right here, negative bc over 3a plus d equals 0. Alright, so now look at what we have. We basically have a PQ method there, or form there, except we want it in this format, y power 3. So basically get rid of this a there. There's an a there, so what we'll do is divide everything out by a. So we can either divide out, but what I'll do is I'll just do it like this, and then divide out by a. So then what we end up getting is we just get a y cubed plus, and then if we divide everything inside, so let's just write it all down. This is going to be y cubed plus negative b over 3 over 3a squared plus c over a, y plus 2b cubed over 27 a cubed minus bc over 3a squared plus d over a equals 0. Like that. Alright, and then this part right here, well, this just equals to our p. And this just equals to our q. So now this is just a giant constant. So what we get is we finally have the form y cubed plus py, plus py plus q equals to 0. So epic stuff there. Alright, now that we have this PQ form of the cubic equation, we can go to step 2 and we're going to solve this equation using Vieta's substitution. So now we can apply Vieta's substitution to transform our PQ cubic equation, this y to the power of 3 plus p, y plus q equals 0, into a quadratic equation. And if I scroll back up, basically what I showed here, basically if we apply this substitution, this Vieta substitution, y equals z plus a blank divided by z, just any number there, or the one we're going to eventually determine. And it's just a function like this. So transform it, and then we're going to get a z cubed plus a number divided by z cubed dot equals to 0, and we can transform this into a quadratic equation. So let's apply this, and let's just write the variable k for that number above z. So let's just write our PQ form of the cubic equation. So y to the power of 3 plus py plus q equals to 0. And now we're going to do let y equals to, this is Vieta substitution, z plus, and we'll write k over z. So we have this, and now what we'll do is we're going to get a, put this inside, so we're going to get a y is going to be a z plus k over z, then cubed plus, now we have a p, so now we have a p, and then we're going to get a z plus a k over z, and then plus a q equals to 0. All right, now this is pretty straightforward. So we're going to just expand this all. And now the idea is going to be we want to get rid of this pz, get rid of this one with all the z by itself terms. So get rid of these ones there. and also find the value of k to get rid of those. So we could expand, let's expand all of this out, because it's super quick. We're using Pascal's triangle. So this is going to be z cubed. Now we're going to get a plus a constant 3. So again, remember Pascal's triangle right here. So it's power of 3. It's going to be 3, then 3, x squared, and then the other one's x, the other one's 1. So we're going to get a constant coefficient 3. Now we're going to get a z squared times it by, so z times z. Now this one times it by k divided by z. K over z. All right, so we get that, and then plus the next one's going to be plus another 3. And now we're going to get z multiplied that once, and then this one's going to be twice. It's going to be k over, k squared over z squared plus pz. Oh no, the next one is just this times itself, 3 times so k cubed over z cubed plus, and now pz. So you need to go through all this. All you need to do is just determine the ones with the pz, and yeah, so this is all that matters. I'll also write this for completeness. Multiply this inside just because it's pretty easy. And as k, p, and then this is z, or yeah, and then plus q equals 0. So what we want to do is we want to cancel this one out with, and now what we'll see is we cancel this out. This and this cancel, so now we're left with a 3z. And then there's a pz. So all the terms with just a z term, because this one will cancel, but we'll have a z at the bottom. This one is at the bottom, a z at the bottom. This one is no z, and this one's z cubed. So all this is the only ones that we matter. This and this. So this is going to be now, this would equal 2, this is, we'll get a 3z, k, and then move this, this plus pz equals 0. So we want to cancel. So it's the same thing as a PQ method, but now we're doing the zeta method. It's the same thing PQ, but we're using, or the Vieta method using the z, and plus k over z. So want to cancel. Yeah, so we want to cancel. That's it. So then, in other words, we're going to solve for k to cancel to make it equal to 0. So we're going to move this over to the other side. We're going to get equals to a negative. Well, all the z cancels first. So cancel, just divide it all out. And now we're going to get move this p to the other side. So we're going to get a k and divide by 3. So k equals negative p over 3. So there it is. So that's our k value. All right, so this would cancel with the negative p over 3. So now we can plug this inside here and then do that again. But we already expanded it. So let's just use this and just replace all the z's. So now we're going to replace it because we know it cancels. We could see that. So it's going to be now negative. So negative z cubed, and this one's going to be z cubed by itself. Doesn't change. And then plus, this one's already canceled. So this one's going to be, I'll just remove this one. And then this one is going to be, well, yeah, this is already canceled. So I'll just put a blank like that. So this is plus canceled. And then the next one's 3z. Then the z cancels here. And this one, now we're going to get a k. K is going to be, well, negative p. So negative p over 3. And there's a z there, like that. The next one's going to be plus k cubed. So that's going to be a negative, and that, oh, this one's going to be k squared. This is going to be plus, because it's a negative squared plus. And this is, if I put a squared there, this is going to be a 9. All right, and now the next one's going to be this one here, k cubed. Now it's going to be a minus, because we have a minus cubed. It's going to be just minus 1. Yeah, so it's going to be minus, and now we're going to get a p cubed over, and then 3 cubed is 27, and then z cubed. Like that, and then plus pz, or the pz's gone. So pz is canceled. So that's this one, and this one's canceled. I'll just remove those out. And then plus, and then this is going to be kp. So it's going to be minus p squared, because it's p times p, and then divided by 3, and then z plus q equals to 0. So we did that instead of putting it in and multiplying it out again, putting this in and expanding it out. And so let's do it like that. So now the next setup is, see what we get next. This one is going to cancel. This is going to be a 1. This is going to be a 3. So in other words, it's going to be this one here. That's a plus. So then this cancels with this. So cancels. So this cancels. And this cancels. Yeah. So that's gone. Now all we're left with now is a z cubed, as the Vieta substitution stated. we're going to get a now P3 divided by 27 z cubed plus q equals to 0. And now this we can convert into a quadratic formula, and to do this, well, this is z cubed. We want to, and this one is z cubed at the bottom. If we multiply everything by z cubed, so let's multiply everything by z cubed. Yeah, so I'll go dot z cubed. What we end up getting is we're going to get a, I'm going to put the z cubes in a bracket for our substitution. So it's going to be z cubed and then squared. So that's times z cubed is going to be z to the power of 6 or z cubed. Or just z cubed squared. And then now this one, move it over to the other side. This one's going to be a q, because this one has the z cubed term. So q and then z to the power of 3. And now what we're going to do is minus, because this one we got rid of all the z cubes. So get rid of them all to get rid of them. And we're going to get a p3 over 27 z's gone equals to 0. Now this is a quadratic equation. And we could see this by, well, if we recall it a quadratic equation in the PQ format, so recall quadratic equation. And if we recall, we had, and I'll put this in the PQ format, so x squared plus, I'll do capital P, because we already have lowercase p over there, then x plus capital Q now equals to 0. And again, this is if we scroll all the way back up to our PQ format. And this is when we had it over here, quadratic formula. All right, so yeah, there's the quadratic formula and PQ substitution method. And again, we converted over this right here. This is, we can divide it out, so we get this x squared plus px plus q equals 0, and then shift it over, and then we end up getting is this x equals negative p over 2 plus or minus square root p squared divided by 4 minus q. All right, so then recall this one, and the solution is going to be x is equal to, it's going to be now negative capital P over 2 plus or minus square root, and now we get a, it is better, plus minus square root and p capital divided by 4, and then minus q, like that. Here, so quickly scroll up, and again, yeah, negative p over 2 plus or minus square root p squared divided by 4 minus q. Again, just to double check that. That's the exact one. Negative p over 2 plus or minus square root, and then p squared divided by 4 minus q. So we get that, and now if we look at this right here, this is exactly it. Now this one's going to be our x, z cubed is going to be our x, and then the q is going to be our p. Now this capital Q is going to be this negative p over 3 divided by 27. So in our case, we get x, well, yeah, so basically the x variable is going to be equal to or equivalent to, because not equal to, just because we already have an x before, I'm just saying in this case, is equivalent to z cubed. So yes, we have x squared, this is z cubed squared. And then the next one is going to be capital P is equivalent to lowercase q. And then the next one is going to be capital Q is equivalent to negative P3 divided by 27. So what this means is, so then this x is going to be z now, z cubed, is equal to negative p divided by 2, so that's going to be q divided by 2, plus or minus square root, and now this p squared divided by 2, that's going to be our q squared divided by, divided by 4, yeah, not 2. And that's going to be, I'll put it like this. And this is going to be divided by 4. And then minus q is going to be plus, lowercase p cubed divided by 27. Alright, and now let's just box this in, just for completeness. Okay, so we've boxed in our z cubed function there. So we've solved it using quadratic formula. Yeah, now we could find our first solution. So that's going to be our step 3. So we could throw this inside the y function and solve our first solution. But there's a plus or minus right here. So that's an issue. But we'll take the plus, and I'll show you that it doesn't matter which one you pick, because you're going to get the conjugate of it. It's going to be the opposite on the other side. And we'll just go ahead and solve and see what happens. So we're going to get let's use the plus side there. And yeah, so we want to plug this inside our y function. So if we go back up, this y equals to z plus y plus k divided by z. So that's our y. So let's just write down our y. So y equals to z plus, and then the k was, recall k is negative p over 3. So it's going to be minus p over 3 and then z. So we want to find our z. So what I'll do is I'll just take the positive side of it and see what happens. Okay, and then we'll just take the cube root of, so cube root of z cubed, and then equals to negative q squared. And then we'll take the plus. So we're taking the plus as opposed to the minus. I'll put that like that. And this is going to be, and then this is a cube root of this whole thing. Like that. Alright, here, just fix that up here. So yeah, so cube root and then negative q over 2 plus. Now instead of the minus, we do the plus. And then this is going to be square root q over 4 plus p over 3 over 27. And yeah, this cubes cancel out. We're just going to get a z. So this equals to our z. So plug this in. Let's get our first solution. I'll call this y1. This equals 2. So this is going to be our z like that. Let's move this. Yeah, so now we're going to get a plug in the z. That's just this whole big giant thing. So we're going to get y1 equals to 3. So that's the first solution. It's going to be, I'll try to compact this because we're going to need this twice. It's going to be negative q over 2 plus square root q squared over 4 plus p cubed over 27. And now we're going to go a minus, and now p, I'll make this even smaller there, just because we're going to need to multiply it by its conjugate. So this is going to be now divided by p, put this 3 like this, and this is going to be cube root. This is going to be a giant one. Let's just do a bigger one. Okay, this is going to be 3. This is going to be negative q squared plus, and now this is going to be q squared over 4 plus p 327, like that. Alright, so in here I just quickly shrunk it over here. So now what we're going to do is, well, whenever you have something like this, whenever you have something like this that's really big at the denominator, we can multiply by its conjugate, or just this same thing but with an opposite sign, and hopefully everything cancels out. So what I'll do is I'll multiply this out, and what I'm going to do, instead of typing this all again, I will copy this segment right here. Oh yeah, this will save a bunch of time. I'll copy this, and I'll paste it. I'll try to make it shrink enough in here. So this one here, and I'm going to shrink it a tiny bit. Let's see, yeah, it fits inside. So now we have this one right here. Alright, so we multiply this, and I'll copy this again, and erase this little dot. Put it like that, and then paste. Put this underneath. Yeah, so again, the reason we have this top and bottom, so we're not changing anything, it's going to be just like that, divided by this. Yeah, so it's a good thing about this one note I can copy and paste. Do this one more time, better line. Alright, and now get rid of these negative. Yeah, make this negative instead of plus. So get rid of this one, get rid of this negative, negative. Alright, now that we have these right here, the denominator has its conjugates, we can multiply it out and then see a bunch of cancellations. So what we get here is, I'll put this right like this. This is going to be going to equal to, now let's just put a giant square root, a cube root, like this. And now we're going to have, we'll move this right here. This is going to be multiplied this, and then this one's going to be multiplied by this one and that one. So in other words, just the same, that foiling out or expanding out. So this one is going to be this, yeah, these ones we can combine these cube roots, because these are just power of 1 over 3. Combine those powers. So that's why we have this giant cube root. Now this one, negative q over 2 times negative q over 2. That's going to be, well, positive q squared over 4, because the negatives come positive. And now this one here multiplied by this one here. But before we get to that, yeah, we'll just do that for completeness. It's going to be a negative. It's going to be positive now, plus q over 2, and then I'll just put it like this because we're going to cancel out dot dot dot. And now the next one is going to be this one times by this right here. So we're going to have, there's a plus times by a negative, so we're going to have a plus q over 2 times, and then dot dot dot. So this, this is going to be negative q over 2. So this cancels. So these ones cancel. All we're left with now is this one multiplied by this one. And now these square roots disappear. So then all we're left with is, the square roots disappear because 1 over 2 plus 1 over 2 powers cancel. So this becomes, I'll put this is going to be a minus. So because there's a plus times minus, and it's minus, and now this is going to be a q squared over 4 plus p 3 over 27. Yeah, because they're the exact same setup there. And again, when you have the same thing, for example, if you have x to the 1 over 2 times x to the 1 over 2, these add up. This just becomes x to the 1 over 1. So, or 2 over 2. Or 2 over 2 equals, 1. Like that. So they just cancel out like that, just for a refresher. Yeah, and whereas this one here, we can't cancel out because these aren't the exact same. There's a plus, there's a minus, so we can't cancel those out. So that's what we have there. And now what you notice is this cancels with this one. Yeah, so then all we're left with is, so I'll put a circle here, circle, and then circle. This cancels with this one. This becomes cube root over, and now we have a P3, a negative P3. Yeah, so this is going to be a negative P3 over 27. So in other words, if we solve this one out, there's a P3, this is going to be, cube root of P3, a negative is going to be negative. Cube root of P3 is just P, so P times P times P is 3, P to the power of 3. And then this one's 27, this is going to be, cube root is just 3, so 3 to the power of 3 is 3, so 27, so we get 3. Now this one right here cancels with this negative P3. So this one ends up happening is, if we cancel all of those, and we get now y1 is equal to, and I'll just copy this out. So yeah, this is going to equal to this one here. All right, and then everything's gone. Whoops, and then move this over. Whoops, I don't know what's going on. All right, here I fixed it up. So I copied and pasted it over here. So we get this one here, and now we're gonna get all this is gone. This whole thing just cancels out, and I'll put this like this, like that. And all we're left with is this one on the top, and that's just a negative. So it's going to be plus, and I'll paste this here, but then we have to switch the negatives. And there's a negative. Yeah, and this is our first solution for that y1 there. Like this. All right, now that we have this first solution, again, note that if we plugged in the negative version of the Vieta quadratic formula, so if we go back above here, so we plugged in the positive, but if we plug in the negative version of this one, then take the cube root and so on, did the whole thing, and then we're gonna have to use the positive conjugate in this setup. Everything cancels, and we're gonna get exactly the same thing. This will be a negative, this will be a plus. So in other words, this would be a negative, this would be a plus, and again interchangeable. So we would just get the positive conjugate, and hence the same solution. So this is the solution for the one, regardless of which one you take, plus or minus, you're going to get exactly the same thing there. All right, now that we have this, now we're going to go to the next step, and that's step 4.1. And the reason it's 0.1 is because this is going to be a quick detour into covering the cube root of unity, which I haven't covered before, so I'll do that right now. And the reason is because we took a cube root right here of the z to the power of 3. So when you take a cube root, you're supposed to get 3 solutions. Here we just got 1. Well, we have a plus or minus inside this quadratic, so that could be a 2. And then you'll have another 3, so that'll be 6. But then this one, doesn't matter which one you pick. So this one, plus or minus, you're going to get basically the inside here as well. So anyways, but nonetheless, we're still going to get 3 solutions for this cube root. Just as taking a square root, you're going to get 2 solutions. For example, square root of 1 is plus or minus 1. And so let's continue further in this. So the cube root gives 3 solutions, just as the square root gives 2 solutions. And we can find these solutions by factoring the square and cube root of unity via the difference of squares and difference of cubes formula, respectively. I'll put this formula respectively. For example, let's take a look at the square root of unity. This is basically w squared. Let's just pick a variable w. Squared equals 1. So now what we'll do now is move the 1 over to the other side. So we're going to get a w squared minus 1 equals to 0. And basically write this as a square. So this is going to be as a difference of squares. So this is going to be the same thing as writing w squared minus 1 squared. And now these links are to my earlier videos on difference of squares and difference of cubes. You get the formulas for them. But for this one, it's just going to be, well, I'll write this actually here. So then what we end up getting is a w squared minus 1 squared. Because 1 squared is just 1. This equals to 0. And now this is going to equal to, before we get further, just expand this out. So difference of squares is going to be w minus 1. So basically you factor this out. It's going to be w minus 1 times by w plus 1. It's similar to the conjugates. So when you have the conjugates, the middle ones cancels out. So similar to this one here. When you have the conjugates, these end up canceling out at the center. Same thing will happen here. So if you expand this out, so w times w, and then negative 1 times w plus 1. So w times w is w squared. W times 1 is plus 1. Yeah, it's just going to be plus 1w. Negative 1 times w is going to be negative w. And then negative 1 times 1 is negative 1. So in other words, these cancel, and you're left with w squared minus 1. So yes, that is correct. Yeah, so what we end up having is just the factors w minus 1, w plus 1 equals to 0. And so then this right here gives two solutions. And these could be, when you plug in 1, you get w, yeah, you get 1 minus 1 is 0. Or if you plug in negative 1 plus 1 is 0. So you're going to get w is equal to plus 1 and negative 1. So two solutions. All right, so now we can do the same thing. So similarly, now we'll have a difference of cubes. Similarly, we're going to have, let's say, the cube root of unity, w cubed equals 1. This should give us 3 solutions. So same thing, let's move it over to the 1 to the other side. So we're going to get a w cubed minus 1 equals to 0. And again, this is the same thing as writing. This is going to be now w cubed minus 1 cubed. Same thing, 1 cubed. So this is difference of cubes. And now the formula for this one, using difference of cubes formula from our earlier video, we're going to get a w minus 1 times it by, so the factors of this is going to be equal to this one, w squared plus w, so w times 1 plus 1, like that. And we can expand this out to confirm. So if you multiply all this out, this is just equals to, multiply this times that, we're going to get a w cubed minus plus w squared. W squared, this one inside here, and then plus w. Now we're going to have a minus, do the same thing. So minus w squared minus w, then minus 1 times 1 is negative 1. So then this cancels with this cancels with this cancels with this, and now we're left with is w cubed minus 1. All right, so then that is what we have. So then what we get is a w, these are the factors, w1, w minus 1, and then w squared plus w plus 1 equals to 0. So now we can solve these. Now we're going to have 3 solutions, and what we end up having is, well, the first one, solutions 1, is going to be w, this one here, w minus 1. So w equals 1 is the first one. And now the other 2 is when this one is equal to 0. So this one we get the other solutions. So the other solutions are going to be, and then we're going to have is, so that's solution 1. Solution 2, we're going to have w plus 1 equals 0. This is a quadratic formula. Yeah, it's a quadratic formula using the PQ method. We'll just scroll back up to that quadratic one. So if we have it like this, it's going to be x squared plus px plus q. So now and it's going to be, and then we're going to have basically equals to this right here. X equals negative p divided by 2 plus or minus, and then p squared over 4 minus q. So let's write that down, minus p over 2. And the p is this one here, p is just 1. So we're going to get is, using a quadratic formula, w is equal to negative p is going to be, well, 1 over 2, and then plus or minus square root p squared over 4. So it's going to be 1 squared over 4 minus q is 1. Let's go back up here just to get that correct. Yeah, so negative p over 2, and p and q are both 1 in our case. So negative 1 over 2 plus or minus square root 1 squared is 1 over 4 minus 1. So that's what we have. And what we end up having in this case, we're going to actually have complex solutions. So this one here, multiply top and bottom by 4 over 4. We're going to get equals to negative 1 over 2 plus or minus, and then this part right here, negative, yeah, this 1 over 4 minus 4 over 4. So we're going to have a negative, we're going to have a negative 3 over 4. So then this equals 2, I'll just go right over here, negative 1 over 2 plus or minus, then put the negative 1 out like that, times by square root 3, then the square root of 4 is just 2. So then this is just I equals to I. So in other words, we're going to get, that's an imaginary number. So that's to get a square root of negative 1, that's just the imaginary number I. So we have a complex solution. So negative 1 over 2 plus or minus, and then this is going to be, I'll write this as I square root 3 over 2. So this is solutions, this is going to be W. So I'll put solutions 2 and 3 equals this one. I'm going to box this in. Solutions y equals 1 is the first solution. This is the second one. All right, and we could refer to these as, we'll write this as W naught equals to 1, just a trivial one. W naught equals 1, just 1 is, 1 like that. And then we'll write, the next one is going to be W 1. This equals, let's do the plus 1, so negative 1 over 2 plus I square root 3 over 2. And then lastly, we're going to go W2. This equals 2. This one, we'll write this as, negative, take the negative 1. So negative, and then this is going to be I square root 3 over 2. All right, so the cube root of unity has 2 complex solutions and 1 real number. Yeah, I'll remove that line right, and I'll box this whole thing out. Those are the solutions there. And now also note that 1 over W1 over this one here just equals to W2. And we can see this by, you could do some polar changes to polar coordinates and so on, but I'll just do this the brute force way. So if we go 1 over W1, and this will be helpful in our, when we put everything together in our solution. So 1 over negative 1 over 2 plus, this is the W1, so 1 over the square root 3 over 2. And now what we're going to do is multiply the top and bottom by the conjugate. Yeah, so in other words, we're going to multiply top and bottom by 1 over, negative 1 over 2 minus I over square root 3 over 2. And I'll move this down. All right, so that's what we have there. Divide this by negative 1 over 2 minus I squared 3 over 2. And now we multiply all this out. And to do that, we're going to go again. This is the conjugate one. So again, the conjugate is just difference of, this is difference of squares. So this one right here is the same thing as writing this one here, difference of squares as we did before. All the middle stuff, as this one, all the middle stuff cancels out. All we'll be left with is the first one squared and then subtracted by the next one squared. So in other words, this is going to equal to, so this equals to, we'll put it over here. We'll put the top normally, negative 1 over 2 minus I squared 3 over 2. And then this equals to the first one squared. It's going to be negative 1 over 2 squared. That's just going to be, multiply by itself. It's 1 over 4, positive, because negative becomes positive. Next one is plus and then minus, so it's going to be a minus. And then it's going to be I squared. And then we're going to have a, so I squared, negative sign, and then square root 3 times square root 3 is going to be 3. The bottom's going to be 4. And then what's the next thing that we get is this equals to right here. So 1 over 4. This I squared is equal to negative 1. So that's the number. It's because I is equal to square root of negative 1. So square it all, you're going to get I squared is equal to negative 1. So this one here, I squared equals to negative 1. So then this becomes positive, 3 or 4. And so this becomes, let's put it right here, equals to 1 over 4 minus, this is going to be minus 1, so plus 1, and 3 over 4 equals 4 over 4 equals 1. So this equals 1, this just equals the top. So this equals to negative 1 over 2 minus I squared 3 over 2. And that's just this one, that's just this right here. That's equals W2, equals W2. Again, just confirmed it there, like that. And here, quickly, I moved it down here, so I put it down like this. So this is, I'll put it like this, 1 over W1 equals to this. So yeah, there it is. We solved it right there. Also, to give more context on this imaginary numbers, here what it does to this, basically to the solution, or basically what it means is, yes, this is a real number. Now the imaginary numbers are basically just a rotation in the complex plane. So note also that these complex factors are just rotations in the complex plane. So that's the thing with complex numbers, it's a point on a plane, whereas the normal number is just a point on a line, and so on. So if we take the first one here, what this means is, if we take, this is the real part. This is linked to my earlier video on showing complex numbers as rotation matrices, which is very, very interesting. So here's the real part. Here's the imaginary part. IM. There's a re at the bottom there. And now we're dealing with, let's say the first one, -1 over 2 plus I times it by square root 3 over 2. Yeah, so the real part in this one is going to be this -1 over 2. So we go -1 over 2 on the left side. So this is going to be -1 over 2, all right? And then we go up, we're going to go up now plus I, imaginary number part, so we're going to go up square root 3 over 2. So it's going to go up like this, square root 3 over 2, and what we're going to get is a rotation. Yeah, so basically that is what we get, and there is an angle. The angle is going to be from here to there. And let's solve this exact trig ratio for it. So this is a theta angle. Let's call that angle theta. And now this one here using Pythagoras' right angle, using Pythagoras' theorem, we're going to have square root 3 over 2 squared plus, and then -1 over 2 squared. This is going to equal to c squared. You know, I'll just put c squared. So that's going to be our hypotenuse there. So this one's going to be equals to square root is going to be 3 over 4 plus, the negative becomes plus 1 over 4. In other words, we get, this is going to be 1. Yeah, so 1 equals 1 squared. Yeah, it's equals to 1 equals c squared, c equal to 1. So this is equal to 1, like that. We'll just take the positive side, just the length over there. So there it is what we have. And we'll get to the exact ratio soon, but then now the other angle is going downwards. It's the same thing, -1 over 2 is real part. Now we're going to go -I square root 3 over 2. So it's going to go downwards like this. And this is going to be 1. This is going to be negative square root 3 over 2 for the second solution. And now we're going to have an angle. I'm going to go like this to make it from the positive, so counterclockwise like that. And that's going to be, yeah, that's going to be, well, we want to solve it. Well, we can solve this first by using exact trig ratios. So exact trig rate or trigonomic ratios. And we can solve this by using a triangle. So what we have is, this is a square root 3 over 2. And the other one is 1. So what we'll do is multiply this by 2. So what we'll get is, and just draw that triangle. So what I'm going to do is draw this triangle right here. We'll multiply it out. So this can be square root 3. Instead of 1, we get a 2. I mean, yeah, instead of a 1, we get a hypotenuse, we get a 2. Like that. And at the bottom, instead of half, -1, but which the positive side, we just multiply by 2. So this is a 1. And then, so in other words, we can continue this out and draw this over, just mirror this out, just draw a perfect triangle. So isosceles triangle. 2, and this is 1, and this is square root 3 height. So in other words, this is an isosceles triangle, all the sides are exactly the same. And in the middle, this is 1, 1, 2. Yeah, so in other words, these are going to be 60 degrees. 60 degrees, and then this whole one is 60 degrees. This one's 60 degrees. And 60 degrees is just going to be, this is going to be pi over 3. Yeah, so this is going to be equals to pi over 3. Yeah, so that is it. Because when you sum all these up, it's supposed to be 180 degrees or pi. So that's pi over 3. So theta is equal to pi over 3. So in other words, this angle right here is going to be 180 minus 60. So 120 degrees. Or pi minus pi over 3 is going to be 2 pi over 3. And then if you look at it from this angle, this one here, or we're going to have basically 180 plus 60 degrees, or this is going to be 240. So the solution is basically take whatever, so it's basically a rotation in the complex plane by 120 degrees or 240, and you get the solution to the cube root of unity. And this one's going to be, in other words, pi plus pi over 3. And that's going to be, this is going to be pi plus pi over 3. So times it by 3 over 3. Yeah, 3 over 3. Like this. It's going to be now, this is going to be equals to 4 pi over 3. Like that. Yeah, so anyways, so that's the angles. Again, just wanted to go over that complex numbers to illustrate it. So basically the solutions are equals to 1, or a rotation of 120 degrees, or 240 degrees about the, in the complex plane. All right, now that we've covered all this with the, basically the cube root of unity has 3 solutions. And now we can go to the next step, so step 4.2, and actually find the other solutions for y. So basically now we have to apply this cube root of unity solutions to our cube root of the z. So if we take this one right here, so what I'll do is I'll copy this just for later, so it saves time from writing. So copy that. And I won't use that right now, but what I'll say is, so let's say we had our first number right here. So we had a cube root of our z cubed, and then this was the cube root of a big number. This equals to cube root of a big number, and this is the same thing as writing, cube root of the big number, and then times it by cube root of unity. Cube root of 1 there. And in other words, this gives you the 3 solutions. So again, this is 3 solutions. And what ends up happening is we have this cube root of 1. So this equals to cube root of that big number times it by the first solution, W0, which is just 1. That's just a principal. It's going to be called the principal root, so the W equals 1, like that. And and I'll just put it as this equals to just a cube root of the big number, just by itself. Now the next one is, that's one solution. The next one is going to be equals to the cube root of 3 times by the second solution, W1. And the next one is going to be, so these are all equal to this, because you have 3 different solutions. Times it by the third cube root solution of unity. Alright, so now let's put this together, and I'm going to paste our solution earlier, or from before. So I'll paste this right here. So this is what we had. And this is what we had as the first solution. It doesn't matter if you picked a plus or minus. So I'll call that, and I'll call this equals to Z1. And then from Z1, we were able to solve for Y1. And there's Y1 right there. Remember what we did? We just plugged that in. So plug into our Vieta solution. I think it was, what was that called again? A Vieta solution. Anyways, so y equals z minus p divided by 3z. And so and we put in z1, we put this one right here inside there. So now we're going to have to find z2 and z3 and so on. Yeah, so this is the first z1. So what I'll do now is I'm going to call z2 equals to just this principal solution times it by w1. So this one right here, and I'll say that this solution is going to be called Z1. This is Z2. And this is going to be Z3, like that. So Z2 is just going to be equal to Z, which is the right there, Z1, equals to Z1 times W1. And then I'll just put a bracket right here. So, and also Z3 is going to equal to Z1 times the second one, W2 right there. And now note that we know that now we've plugged this all inside, or inside the Y solution. So now what we end up having is Y, I'll put a bracket like this. So we have this. Oh, actually, I'll leave that right now. Not a bracket, line. But anyways, so now we're going to put the second solution. So Y2, remember this equals the Vieta solution. So Z2 minus P over 3Z2, and there's a W there. Well, actually, no, that's afterwards. This is just Z2. So now this equals to Z1 times by W1. This is the first one there. Then minus P times by 3 Z1 W1. And we also know that we solved earlier that W 1 over Where is that number right here? Yeah, this right here. So we also note that 1 over W1 is equal to W2. So now, in other words, in our case, yeah, we have the Z1 W1 now divided by, this is a 1 over W1, so this equals 2, this becomes W2. So this becomes Z1, or I'll put the W's in front, so W1, Z1 minus, and then this is going to be W2P over, or actually, I'll put the W2 in front, so W2, and then this is going to be P over 3Z1. Alright, so we got this. Now, basically what this means is we just take our solution for W1, for Y1, then we add the W1 and 2 there. So we'll take this right here. Alright, so there's our W1. So now what we're going to do is we're going to shift this over. We're going to shift this over as furthest as we can. Yeah, so that's a good spot there. And now this is going to be W2. So then W2 is going to be, put a W2 in front of this one. And what is W2? Because this is just a Z1. This is a Z1 becomes now the negative conjugate of Z1. And then the bracket for, and I'll put the complex number. And so W2 is -1, and then -1 over 2 minus I squared 3 over 2. So this is going to be, I'll put this all up from or backwards. Over 2 minus -1 over 2. Like that. So that's our W2. Yeah, alright. So we got that. I'm gonna just shift this over. So yeah, it saves a lot of time from actually having to type it all over again. So move this over here and put this bracket, and I'll erase this one. And I'll put, now it's going to be the I squared 3 over 2 plus, going to have to fit all of this in. This is 2, and then this is going to be -1 over 2. And that's our W1. And this is going to be now our Y2. So there it is. There's a solution. All right. And now we have that. And similarly, I'll do it for completeness. Yeah, similarly, we're going to, and I just fix the spelling right there. There's no extra I in the middle of R and L. Anyways, similarly, we have, Y3, this equals to Z3 minus P over 3Z3, and I just put it for completeness. This equals to Z1, now he's going to multiply by W2. And then minus, and then it's going to be P over 3Z, Z1, W2, and then 1 over, so 1 over, W1 is W2, so flip that around, this becomes the W1, so this just equals to, put that in front, W2, Z1 minus, and then we're going to get a, this multiplied by W1, so flip that over, P over 3Z1. So in other words, it's the exact same thing, but now we flip this one and this one. This becomes W, this is W2, this is W1, this becomes W2, this becomes W1. So we can literally take this entire thing, so copy this, and then multiply, paste it. So we get this whole thing, like this. And now what we do is, this becomes a positive. That's our W1. Now this becomes a negative. This becomes W2. So that's all it is. That's W2 and that's W3. Oh yeah, and then we erase this. Like that. Alright, and now finally let's take a look at step 5, and that's putting everything together. So we have the solutions to Y1, Y2, and Y3, but we need to find what X1, X2, and X3 are, and also replace all these PQ values with the original ones, because remember the cubic equation is ax cubed plus bx squared plus cx plus d. So in other words, we need to have the terms a, b, c, and d inside, not this PQ and stuff. So anyways, so recall like here. But let's find the values of P and Q. So recall from earlier one, I'm just going to copy and paste that. So let's go all the way back up to the P and Q right here. So recall here, but also I just realized I made a mistake. This one here, but it doesn't change the rest of the solution. Just this right here. Remember, I went from negative b squared over 3a. Then I suddenly added an extra 3 there. This is actually a 2. So this is a 2, and that's a 2. Yeah, and then I just divided by a inside there. Yeah, I just divided by a and a, so it'd be never change. So anyways, so that's a 2 there. I'll modify that in the video there, but again, it doesn't change anything because we used PQ the whole time. So the only time that we're using the actual values is right now as we speak. So I just realized that mistake after I made this part actually a couple times. Keep making mistakes. This is very hard to do this without making mistakes because there's just absolutely so many variables and so on, trying to do this all in a video. All right, so we have that. That's the terms right there. And also recall the value, the substitution that we used. So recall the substitution, or and, instead of writing recall, I'll put and. Yeah, so and, let's go all the way back up to the substitution. And this is all the way over, yeah, right here. So the substitution right here, oh no, that's the original, this is the other one. This is the Vieta substitution. Let's go to the one before, and that one is right here. So we use the substitution x equals y plus k, where k is equal to negative b over 3a. So in other words, x equals to y minus b over 3a. Let's go all the way back down. All right, so now we have this. So then we have x equals to y minus b over 3a. All right, so now we have this. So let's solve this now for the first term. So the first one's going to be x1 is equal to y1 minus b over 3a, like that. So this equals to, well, what's our y1? Let's just copy and paste our y1 and scroll all the way back up to our y1. That's this one right here. So we take our y1. Whoops. Okay. All right, yeah, here I'm back. I don't know why it's teleported. But anyways, so there's our y1. I'm going to copy this y1 just to make it easier. So there's our y1 from earlier. And let's paste this right here. So I'm going to paste this right here. So y1 is equal to 3 negative q over 2 plus all this. And then we just subtracted by b over 3a, like that. All right, so now we could plug in all our values here. So plug in all our p and q inside, and we basically get our stuff there. So this is going to have now our x1. I'm going to move it all the way down here. So x1 is equal to, well, the cubic root of now the q, negative q over 2. So I'll take our q. So I'll copy this q. We'll paste the q right here. And we're going to need to shrink it, and we'll make everything look nice in a bit. Shrink it a bit more, maybe. So there is our q, and this is going to be a cube root. So this is our q, but this is going to be a negative, though, and also divided by 2. So the 2's cancel. This is going to be a negative. Whoops, this is going to be a negative. This is going to be plus. This is going to be a negative. And this is divided by 2. So this is going to be 2a. This is 2a. This is going to be a 6. And now the next one is, yeah, so that's what it is, because we're dividing by, this is negative and a 2. So now we're going to do a plus. Now we'll do a square root sign. So I'll make this bigger. We'll fix that up in a bit. Now that we add the q again, so paste this again. And now we're doing a q squared. So I'll move it like this. I'll put a bracket. We will square this, but also there's a divide by 4, but that's just 2 squared, so we could bring the 2 inside. So then bring the 2 inside, it will cancel all the 2's. So this, the 2's will cancel. This will be a 6. This will be a 2a. So in other words, we have the exact same thing here. Whoops, this would be 2a. This is exactly the same thing as this one. Let's fix these all up. Yeah, this is exactly the same as this, except there's a negative signs on these. This is a negative sign. So this is going to be b3 over 27a3. This is b3 over 27a3, but a negative is a plus, is a negative. bc 6a squared, this is going to be d over 2a. This is negative d over 2a. So what we'll do is multiply this by, well, negative 1 squared. And this doesn't change anything because this is equals to 1. So we'll basically change it to a negative because you have a squared, it becomes positive anyways. So make this just so it's exactly equal to this one. So just for just to make it uniform. So this is going to be plus. This is going to be minus. All right. So that's what we have there. Make this a bit smaller. All right. So that's what we have, and we're still on this one here. And now that's going to be plus p cubed. So p cubed is this right here. Or, yeah, so I'll just take this, yeah, I'll just write that down. So negative b squared over 3a, then plus c over a squared. So negative b squared over 3a squared. So this is going to be bracket negative b over 3a squared. This is a squared. This is, yeah, b squared over 3a squared. And then this is going to be plus c over a. And now this is cubed. There's c over a, and now we're going to cube it right here. Cubed. But also there's a 27 there. It's divided by 27. That's just 3 cubed. So we could divide this all out by 3. So in other words, put those inside. It's going to be a 9. And this one's going to be 3a. Like that. Alright, so we have that. Now let's just fix up the square roots and cube roots. So this is going to be like this over that. I'll make this, I'll write it from this right side so I can see my pen. Alright. And now the next part is, I'll actually fix this up a bit better. Just write it like this. Alright, so we have that. And now this one right here is the cube root. This goes above it there. I'll fix this up. We'll do this one more time. Alright, here I just pause it and fix that up like that. So there's that one. And that's just this part. Now we have to do the exact same thing. Yeah, notice there's the plus right here. So this one's a plus, and now becomes a minus. Yeah, so that's a plus, then a minus. So in other words, right here, this is a plus right here. The next one we're going to have to do is a minus, because this is in front of the square root right there. Yeah, so what we'll do is, and also we need to account for this negative b over 3a. So copy this. And again, I think it's the 4th time I had to redo this last section, putting it together, because I kept making mistakes. Yeah, this is absolutely impossible to put this all in order. Okay, so now we have this. And what I'll do is shrink this a tiny bit. Move this over. And this becomes a minus. That's the only thing different. This is exactly the same thing. There's a cube root, negative q over 2, etc. And then the only thing is this plus, this becomes a minus. And then we have this negative b over 3a. And this becomes a plus, like that. So plus that. Alright, so there is our x1. Yeah, so there's our x1. And now the x2 is basically the exact same thing, so we have to apply the conjugate. So remember, this is x1 is equal to y1 minus b over 3a. Now if we go scroll back up, x2 is going to be equal to y2 minus. So equals to y2 minus b over 3a, and y2 is exactly y1, but we have these the complex complex factors right there. This is w1, this is w2. Yeah, it's w1, w2, and w1 and w2's only difference is the minus sign. So plus, minus, and these are exactly the same thing. Cube root, negative q over 2, etc. Blah blah. Yeah, dot dot dot. And then for y3, it's exactly the same thing. Instead of w1 and 2, we have w2 and w1. And w1 and 2's only difference is plus is w1, minus is w2. So this means we can just copy and paste this whole thing and then add the complex conjugates. The complex factors. Okay, let's copy this. We're going to copy this. We have to make it a bit smaller. Alright. It's going to be like this. This is going to be a bit smaller. Let's move this in. It's a bit slow because of it just gets more and more complicated once I have a million text. So we have this. I'll make it a tiny bit even smaller there. Alright, so we have this. This part right here gets shifted to the right. Now this was going to be multiplied by the w1, which is negative 1 over 2, plus I squared 3 over 2. Like that. So it's multiplied by that. And now this part right here, we're going to shift this over. So shift this one over here, and we can just copy this part right here. I'm going to move this a tiny bit out of the way and fix this up. This will be a negative 1 over 2, like that. And yeah, and this is better line like this. One more. Alright, here, yeah, so we have that. I'm going to move this plus, put it right here, copy this one, and then copy and paste. yeah, copy and paste it here, and then just change this into a minus sign to a minus. So for the W2, and this one is a plus, and this is going to be our x2. So there's that one. Now the next part, and also this somehow didn't copy paste 3a. Okay, there's a 3a. So again, there's the plus, minus in here. There's a plus, etc. And this should be all. I'll move this a tiny bit to the left away from my line there. All right, so this is it. And now the last one is just the easy one. Is just the x cubed. I mean the x3. So it takes a while to copy because it's a million text. It still didn't copy the a there, but anyways. So paste this over. Yeah, so that is what we have, and add this last term, a. All right, so there's our a. This is going to be now y2, so it's a minus. This one's a plus, and that is it. Yeah, so that's it. And now what I'm going to do is quickly just double check from that big YouTuber. He puts the solution at the end. He didn't even go through it all. He just added it at the end as a screenshot, or just a quick image there. So basically, double check. So here is our cubic equation: ax cubed plus bx squared plus cx plus d equals 0. So again, double check and summary. So we have this cube root right here, negative b over 3, 27a3 plus bc 6a squared minus d over 2a. That's this part right here. Yeah, and then we have this plus square root and exactly the same term inside there, and then squared. And this is exactly the same thing as this, squared, plus now negative b squared divided by 9a squared plus c over 3a cubed. Then, yeah, this part right here, cubed. And yeah, and then these ones are exactly the same thing, except this would be plus and b minus, and there's a minus 3b over 3a. So plus, minus. And now this part here is the conjugates. This is the W1. So W1 is exactly the same as this, but now we have a negative 1 over 2 plus I times square root 3 over 2. And then the next other one's going to be the same thing, but negative sign. And the other one's going to be negative, and this is x3. So I copy and paste it. Yeah, that's x3. So it's a negative plus instead of plus or negative. All right. And this is going to be negative. Yeah, this is going to be plus, negative, negative, plus. And that's exactly the same thing as these right here, and there's again plus minus here, plus minus, and there's a negative b over 3a. So yes, absolutely epic stuff, and I might be the only one on YouTube or in the world that has a video putting this all together like that. But again, I had a copy and paste tool there, so that's pretty cool with OneNote instead of writing this all out. And again, I made so many mistakes in this one. I had to keep redoing it, but I did note that I did capture that mistake. I did way early on. But anyways, that is all for today. Hopefully you enjoyed, and yeah. And hopefully you enjoy this epic video on cubic formula. Again, I did this because someone in Substack asked me to do it, so I said sure, why not. Anyways, that's all for today. Hopefully you enjoyed, and like always, you can download these exact notes in PDF format in the link in the description below, as well as viewing it on the Hive blockchain. And again, all the timestamps and so on, and the links will be in the description, in the video description. Anyways, that's all for today. Thanks for watching, and stay tuned for another math easy solution.